While we are discussing rate, it's important to go through a quick note about catalysts. As they relate to chemical reactions, catalyst can work in a number of different ways and often an enzyme is a catalyst. Those have many different functions and that will be discussed later. But now what we need to know about catalyst is that a catalyst somehow lowers the activation energy of a reaction. And because of that, it increases the initial rate. See over here. So if you decrease this activation energy, lower the activation energy, then it increase the initial rate. It makes it easier to overcome that activation energy necessary to get into our transition state. So this is your transition state, fine, and make the reaction move forward. You have seen this graph of reaction quotient on x-axis and activation or energy. It could be gives energy or it could be gives energy G, delta G, or it could be an enthalpy, and it could be a pure energy E. Okay, but what a catalyst does is it lowers that activation energy. And what a catalyst does not do is a catalyst does not affect the equilibrium concentration of things. So K will not be affected by catalyst. Simple कि catalyst क्या कर देता है, low डिक्रीज कर देता है एक्टिवेशन एनर्जी को एंड रेट को इंक्रीज कर देता है. एंड इसकी वजह से इक्विलिब्रियम कॉन्सेंट्रेशन है और इक्विलिब्रियम कंडीशन से वो अफेक्ट नहीं होती ना. रेट affect rate means equilibrium constant K is not going to be affected by a catalyst. Okay, so K will not be affected by catalyst, and part of this is because notice that it lowers the activation energy for the forward reaction and it also does that for the reverse reaction. So you will still reach a point where see what we have in the reaction, we have forward reaction and at the same time we have reverse reaction. We will still reach a point where the forward reaction and the reverse reaction are moving in the same rate, and because of that we will reach equilibrium. And for any reaction what we want to reach to the equilibrium, but a catalyst does not affect the equilibrium concentration. So equilibrium concentration पर catalyst का कोई भी effect नहीं होने वाला है. So it is not going, even it is not going to affect equilibrium concentration or overall equilibrium conditions. What else catalyst does not do is it does not change the overall energy, right? That's because notice that if you compare to our initial state, this is your initial state and final position, it does not matter whether you take catalyzed path or uncatalyzed path. आप कोई भी path ले लो, चाहे whether it is a catalyzed path and uncatalyzed path, but in either case have we are going to have delta, this delta E, and this delta E could be the change in enthalpy, it could be the change in Gibbs free energy, or it could be expressed in it could be exothermic. In gate exam or in interviews they try to trick you into asking about whether catalysts change the equilibrium position or whether they change the overall energy difference between the reactants and the products, and the answer is no. What catalysts do is they increases the initial rate of the reaction and they do that by lowering the activation energy. The way that they operate is a lot based on biomolecules, and it can also be related to the Arrhenius model, Arrhenius way of expressing rates, because the Arrhenius equation consider the orientation and the energy threshold. Necessary for a energy threshold is necessary for a collision. Both orientation and energy threshold is necessary for a collision, for the collision of molecules to result in a reaction. A catalyst does something like changing the orientation of a molecule, which makes it easier to react. With that an example, here the catalyst is working through the Arrhenius collision model. But the most important thing with the catalyst is to realize that they lower the activation energy and increase the initial rate without changing any of these quantities. So that means the equilibrium or any of the overall energy exchange that occurs as we move throughout this reaction. So that's this important thing about the catalyst for chemical reaction. That's all you need to know for those.